Yes, welcome back to our next class. And in today's class, we are looking at this Jupeb past question 023, 024 academic section. So let's quickly look at the question. So the question says, calculate the Broglie wavelength. Calculate the Broglie wavelength for a particle moving with the speed of solution. They are giving out our speed. So we sort out our parameters as a indication. So velocity, speed, same thing as velocity. So velocity is given to be 2.30 times 10 raised to the power 7 meter per second. So now the next one, if the particle is I and electrons, that means what the question is trying to tell is that the question says calculate the de Broglie wavelength. The Broglie wavelength, that is lambda. Lambda is unknown. We have to calculate that now. So when the particle is an electron, a proton, and also a mass, a 200 grams bullet. So now this question is telling us that we should calculate this wavelength, the Broglie wavelength, in each of these. That means we calculate when it is an electron, when it is a proton, also when it has this mass wavelength. So now let's solve for this man. When it is an electron, when is that electrons? We know that electrons is simply a flow of charge in a circuit. So now, if you look at this, our formula. When you need to remember the formula first. So formula for solving for the Broglie wavelength is given to be lambda equals to h all over m. We know that m is our mass, v is our velocity, this man is constant, Planck constant, it's called Planck constant. And Planck constant, the value is given to be h, the value is given to be 6.67 times 10 raised to the power minus 84. This is the constant. This is the value for this man. This man is constant. Then this man is called mass. And then at this point now, you are going to refer this mass in terms of mass of an electron. Because if you look at the an electron. Okay. Given our value, Planck constant, this man is constant. These are value for Planck constant. And then here is our mass of electrons. Mass of electrons, because here was mentioned electrons, so that means our mass will be in terms of electrons. So mass of electrons is a constant, so it's also given as to be 1.6. Sorry, not 1.6. It's 9.11 times 10 raised to the power minus 81 kilogram. That's our mass of electrons. So from there, looking at that, we have gotten all our values. So what we need to do is substitute and get our lambda, our de Broglie wavelength. So lambda equal to here will be 6.67 times 10 raised to the power minus 84 divided by 9.11 times 10 raised to the power minus 81 times our velocity is given in the question 2.30 times 10 raised to the power 7. So my people, once such question is given to you, you need to recall all this. Recall that this man is constant because this man is constantly in the equation. So you need to have at the back of your mind that this man is always constant. The mass of electrons, because here is mentioned electrons. That means you use mass of electrons. Because the question says calculate the de Broglie wavelength in terms of an electrons, and then at this point they are gotten in terms of electrons. So let's quickly check what this man will resolve to. So we have that. Let me take this thing of 9.11 times 10 raised to the power minus 51 times 2.30 times 10 raised to the power 7. So my people, I'm having that this man, the denominator is given me as lambda equals 6.67 times 10 raised to the power minus 84 divided by given me 2.0953 times 10 raised to the power minus 53. So what I'll do is that I'll quickly divide this one to get my final solution. So if I do that, 6.67 times 10 rest of our minus 84 divided by 2. Divided by 2.095 times 10 rest of our minus 23. So our answer is given us lambda, or at electrons, lambda is given us 3.1, 3.2, 3.1833 times 10 rest of our minus 11. So this is our lambda. This is our final answer. But you can quickly take this man and keep this man in terms of nanometer. At this point, you need to remember that lambda is in meter. Lambda is in meter. So taking this man to nanometer, you need to take this man to nanometer. So taking the nanometer, we have that lambda electrons is given us. That will be 3.1833 times 10 raised to the power minus 11 times 10 raised to the power 9. So what I will do, I will quickly subtract this man. Minus 11 plus 9. So here is giving us minus 2. So that means our lambda electrons is giving us 3.1833 times 10. This includes our lambda is giving us 3.1833 times 10 raised to the power minus 2 in meter. That n meter stands for nanometer. That n that you see there stands for nanometer. So that is when it's at electrons. When it's an electron. So let's check when it's at proton. So now when it's a proton, we will still apply the same formula. We know that lambda equals h all over. At this point, here will be mass of proton, then velocity. So from here, lambda proton will now give us, this man is constant 6.67 times 10 raised to the power minus 84 divided by mass of proton is going to be 1.67 times 10 raised to the power minus 27. That our velocity is 2.30 times 10 raised to the power 7. So what I'm going to do is just for me to multiply and divide in my final solution. So let's take the denominator first. So denominator says 1.67 times 10 raised to the power minus 27 into 2.30 times 10 raised to the power 7. So we have that our denominator, that is lambda proton, is giving us 6.67 times 10 raised to the power minus 84 divided by, here is 3.841 times 10 raised to the power minus 20. So that's what it's giving us. Looking at this from here, I'm going to divide it in my final solution. So 6.67 times 10 raised to the power minus 24 divided by 3.841 times 10 raised to the power minus 20. We are having that. Let me take this solution. 6.67 times 10 raised to the power minus 84 divided by 3.841 times 10 raised to the power minus 20. So now we are having that lambda. Our lambda proton is equal to 1.74 times 10 raised to the power minus 14 millimeters. That is our lambda when it's a proton. So we can quickly convert from meter to nanometer. That's by saying by multiplying this man with 10 raised to the power minus 9, 10 raised to the power 9, 10 raised to the power 9, I'll convert to nanometer. nanometer. So if I do that, that means 14 minus 14 plus 9. So it's giving me minus 5. That means lambda photon equals to 1.74 times 10 raised to the power minus 5 meter. So that is when it is at photon. So let's check when it is a 200 grams bullet. So I know that our formula is our 200 grams bullet. And when you need to convert this man to kilogram, you need to convert this man to kilogram. So that will be 200 divided by 1000. So that means our mass is 0.2 kilogram. So if we substitute lambda equals to h over n, so that will give us 6.67 times 10 raised to the power minus 84 divided by 0.2 times 2.30 times 10 raised to the power 7. So if I take the denominator, let's see what we have at the denominator. 0.2 times 2.30 times 10 raised to the power 7. So we have that our lambda is giving us 6.67 times 10 raised to the power minus 84 divided by our denominator is giving us 460. So for me to get this man, please divide this man. So if I divide that man, I'll have something of this pattern. 6.67 times 10 raised to the power 6.67 times 10 raised to the power minus 84 divided by 460, 1, 2, 3, 4. So we end up having that our lambda is giving us 1.45 times 10 raised to the power minus 40 meter. So this is when it's at the equivalent of at the mass of 200 grams of bullets. So it's giving us this man. So if I change it to a nanometer, we multiply this man with 10 raised to the power 9. So if I use subtract this, because here is 10, here is 10, I will use subtract the power. So the power will give us minus 40 plus 9. So here that means our lambda is giving us 1.45 times 10 raised to the power minus 81 nanometer. So this is where we end our answer for today. This question, once you are given such question, this is how to solve this question. That is taking step-by-step solution. Because if you look at the solution was given in terms of electrons, proton, and this mass. So what do you need to do? You need to have in mind that once they mention electrons, that we need to use mass of electrons is constant, which is this man. This Planck constant is constant, which is this man. And then once it's in proton, it means you need to use mass of proton. Mass of proton is constant, which is this man. 1.67 times 10 raised to the power minus 27 is constant. So with that, and solve the solution. And with this one is given already. This one was given already. So this will end our class today. Please follow up for more explanation based on this the Broglie wavelength calculation. Thank you very much. Check on YouTube channel. Check on my YouTube channel. Subscribe. You'll see more of this man. You'll see more solution of this man. Thank you very much.